Okay, guys. Question number 1 and question number 2 from last night or tonight's homework, Tuesday night's homework, are just examples of combining like terms and using the distributive property. The first problem is combining like terms. That's the primary strategy we need to use. So I have an example here that is more or less the same steps and the same ideas as the one in the homework. So let's first of all make sure we understand what we know what we mean by like terms. So in this example, we're going to underline some like terms. 6x to the 7th. A like term would be anything else that uses 7 as the exponent. So negative 5x to the 7th is a like term, and it's good to go ahead and label those. Any term that uses to the 5th power would be a like term for this term, and actually I don't see any others. So when we get down to the combining step, this term is just going to remain 2x to the 5th. Any term that uses negative 5x squared, let's label those with purple, and we got one right over here, so the purple terms are going to be combined. And we know we're combining them because they have the same exponent and the same base. X squared is what makes them like terms. Let's label a few others. We have a linear term here that's x. Remember, anytime it's just the term x, it's like having a silent 1 as the exponent. And we do not see any other terms that are just to the 1. So there's only one that we'll label in black. And then there's a couple other here that we haven't labeled yet either. So for example, x to the 4th is a type of term, and there aren't any others. And then also we have a constant term at the end, plus 4, that has no variable, it's just a constant. You can only add and subtract terms and simplify them if they share a variable base and an exponent. So, for example, you could not combine y to the 7th and x to the 7th. Yes, they have the same exponent, but they have different bases, so this would not be a good example of combining like terms. So let's actually go ahead and get started. In this case, we also should address the parentheses. Anytime you have something in parentheses plus something in parentheses, it's perfectly fine just to drop the parentheses. So this is 6x to the 7th plus 2x to the 5th minus 5x squared plus x minus 3, and then minus 5x to the 7th plus 2x to the 4th minus 10x squared plus 4. I'm not going to relabel the like terms. I think we know it's the 7ths that we're going to combine, the 5ths that we combine, the squareds that we combine, and not everyone has another term that we can combine it with. Let's go ahead and rewrite the next line, and let's start with the largest exponent. So we have 6x to the 7th minus 5x to the 7th. So 6 minus 5 is 1, so this will give us 1x to the 7th. The next largest exponent is to the 5th power, and there were no other things we underlined with dark blue, so we're just bringing down 2x to the 5th power. The next exponent, I believe, is over here. It's the 4th. There are no other things that we underline in green, so there are no like terms for that term, so it's just plus 2x to the 4th. The next exponent is minus 5x squared and minus 10x squared. So if you have a negative minus a number, what this ends up being is negative 15x squared. We have our one linear term plus x. And then we have our one constant. Oh, you know what? I'm so sorry. I'm not going to go back and redo the video because we got such a good start. But there were two constants. There's a minus 3 in this scenario and a plus 4 in this scenario. I forgot to label that term. But anyhow, if we have minus 3 and positive 4, and we add that together, that's just plus 1. And that's our answer right there. We cannot simplify this anymore. We can only add and subtract these terms together if they have the same exponents. This is the only exponent with a 7. This is the only term with an exponent of 5. This is the only term with an exponent of 4. So none of these can be combined. But anyhow, number 1 is just a combining like terms example. I also think it's plus. So a good first step would just be to drop the parentheses, and that's something that we can only do because it is plus. As we'll see in some later problems that have multiplication, there's more work to do if it's something other than plus. Let's look at number 2 also. Just like this was just combining like terms, this is really just a distributive property problem. It's just that once we use the distributive property, there's going to be some funky terms to deal with. So here what we need to distribute is 7a cubed b squared c. We need to multiply it by 3b. We need to multiply it by ac, and we also need to multiply by 3abc. And actually, I tell you what, to make this problem a little more interesting, I want to add something to these terms. Let's make this b cubed. Let's make this a to the 4th. And then let's just add on c squared and a b squared right there. All right, I think it's actually going to make it a better problem. I apologize if you hit pause and tried to work through this problem, but hopefully that's not anyone's case. Okay, let's start multiplying. The first thing we need to do is multiply this term by this term. Now, when you're multiplying terms that have kind of different parts to them, different variables and different values, what you also need to do is multiply the common bases. So here's a regular number 7, here's a regular number 3. 7 times 3 is 21. Here's an a cubed. There are no other terms that involve a, so that's going to stay a cubed. B squared will be multiplied by b cubed. And the rule for when you multiply terms with exponents is you add the exponents together. So when we add this exponent and this exponent, we get b to the 5th. And then lastly, we have c. There are no terms here that use c as part of this larger term, so this is just a c. Okay. Let's take 7a cubed b squared c and distribute it to the next term in parentheses. There are no constants, right? There's a silent 1 right here, but other than that, there's no constants. So it's just 7 times 1, or it's just the 7. We have an a cubed and an a to the 4th, and so we're going to add those exponents together. That's the rule for multiplying, so it's a to the 7th. This term doesn't use b, so we just bring down b squared. It does use c. C times c is c squared. That's what c means. Or we could also just remember that these are like exponents of 1. 1 plus 1 is 2. And then now we have the last term to use. So first of all, I should point out there's this minus symbol right here. It's very important to respect. This will be 7 times negative 3 for the multiplying of the constants. A cubed times a is a to the 4th, because we add on that silent 1 to 3. B squared times b squared, well, we're going to add those exponents together. That's b to the 4th. And then c to the 1st times c squared, that's a total of 3 c's. 1, 2, 3. We add those together, we get c cubed. And at this point, we're done. We actually can't do any more simplification, because if we looked at each term, as we set up here, to add things together, they have to have the exact same exponents and the exact same bases. B to the 5th and b squared use different exponents, so that's one of many reasons we can't combine these two terms. Or a to the 7th, a to the 4th use different exponents, so it's another good reason we can't combine these two terms. So number 2 in tonight's homework, it's just distributive property. We're going to multiply what's ever out in front of the parentheses by each term on the inside. We're going to distribute, distribute, distribute. And then just remember, regular numbers get multiplied by regular numbers, what are called constant coefficients. So a coefficient times a coefficient. And then each term, the a's would be multiplied by the a's, the b's by the b's, the c's by the c's. And if you're missing an a or a c, then you just bring down a cubed, bring down c to the 1st, etc., etc. All right, 3 and 4 are also distributive property, but distributing binomials where we have a lot more distributions to do or a lot more introductions to make. So go ahead and check out that video.